Okay, this time I'm going to explain you how shortest job first scheduling algorithm works, and for this example I'm considering non-preemptive version of the algorithm, and you can see the set of data that I used to explain round robin algorithm, the same set of data, and I have a process queue. This actually should not be the queue. This will be the timeline. I'll rename this as process timeline. Okay, yeah, let's get started. Before we get started, I have to say that how shortest job first algorithm works. It's based on a simple theory, which means that whatever is the shortest job first, it will execute it first. So keep that in mind. Right, P1. P1 is the first process, and its arrival time is 0. It has a burst time of 4, which means that this is the shortest job at the moment. So this one will be executed directly. So the timeline will be 4, and process P1 will be executed, and I'll mark P1 as red to clearly mark that it's executed. So since in the shortest job first algorithm, job gets executed completely in one cycle, which means that there is no queuing. Right, timeline is 4. By time 4 we have P4, P3 and P2 come to the processor, so we have to consider these three, and from these three, P4 has the lowest burst time, so we have to execute P4 next, and have to mark P4, and since the burst time is 1, the timeline will be 5. Next, by time 5 we have no new process arrived. It's P2 and P3 still, so between these two, P2 has the shortest burst time, so I'll execute P5 next, and 5 plus 5 means time unit line is 10, and this will be P2. Sorry, this will be P2. Right, time is 10, which means that processors 5 and 6 also have arrived. You can see the arrival times here. So for the next calculation, I have to consider both P5, P6 and P3. From these three, P6 is the shortest. It has burst time of 2. So I'll mark P2 as the next one which is executing. Sorry, P6, and I'll mark P6, and this should be 10 plus 2 is 12. Right, left P2 and P5 are left. From these two, P5 is the shortest, has a burst time of 3, so I'll run it next, and it should be P5 here, and the timeline should be 12 plus 3 is 15. Right, next P3 is the one left, and it has a burst time of 6, so I'll mark this one in red, and it should be P6, and timeline should be 21. Okay, timeline should be 21, and if we consider the waiting time, so let's add a new column named waiting time. And if you take process 1 came at arrival time is 0, and it started at 0, so it started directly, so the waiting time is 0. And if we take P4, it started on time 4, and P4 arrival time is 4, which means 4 minus 4 is 0, which means that it also started directly without waiting. And if I take P2, its started at time 5, and arrival time is 1, which means it had to wait for 4 time units, so P2's waiting time is 4. And P6, let's see, P6 start time is 10, and arrival time is 7, which means it had to wait for 3 time units. And P5 start time is 12, and arrival time is 6, which means it had to wait for 6 time units. And something wrong. What is it? This should be P3 actually, not P6. Right, P3, its starter time is 15, and this should be P3 because it's the last one, so my mistake. And P3, its start time is 15, and arrival time is 2, which means it had to wait for like 13 time minutes. So if you compare waiting time of the processors, some processors had to wait a long time to get executed, I mean even to start, but others get executed directly. So it depends on the situation whether this algorithm is useful or not. But in next example I will show you how the same algorithm, shorter job first algorithm, but it's the preemptive version.